Hi, I am Sandeep Godmacha and this is my Valura AI assignment walkthrough. So this is the architecture. So this service is a fast API microservice that accesses the intelligent layer for investor queries. And the main goal is to safely route each request to the right special behavior, stream the results back over SSE, and make the system resilient when the LLM is not available. So this is the request flow is like simple but deliberate. Like first the client will give, we will post the query, and the first thing that happens is the safeguard. That is a pure local check, no LLM call and no network call. If the query is clearly harmful, the request is blocked and immediately, and the user receives a structured SSE response with the reason. And if the guard passes, the service loads session history and then runs to the classifier, the intent classifier tries one LLM call first, and then but if that fails, it falls back to the rule based routing, so that request still completes. After classification, the router sends the query to appropriate agent. Here we have many agents like portfolio health agent, market agent, and all that. The main Our main agent is like portfolio health agent, and after classification we send it to appropriate agent, and the implemented agents return structured outputs, and unsupported agents return structured non-implemented responses instead of errors. So the final response is like streamed as SSE events, like metadata first, then result, and then done. Like we also have like a request lifecycle, like the user post query, fast API query, and all that, safeguard, session store, classifier, router, and all that. So the classifier decision flow is like the input query. We will try LLM classification and the validate structured output. If it is success, classifier output, or if it is a failure, rule-based fallback. We'll look into the postman. Like we have the queries here. Like this one is for the safeguard. Like this is the result for safeguard. Like it blocks, and first we'll get the metadata and the accurate result. And the other thing is like portfolio health. So we will have the metadata like this, like safeguard, blocked or message, like, and all that. And this is the result of portfolio health. Like it will show our concentration risk based on the user query, like top position, like what happens, how is the performance, and total run, and cost basis, and all that. And it will check the observations, and it will give like severity, whether it is warning or light, and text, and also, and it will also provide the disclaimer at last, like this report is for informational purpose only. Like this, we'll get the accurate JSON in return for the user query. And this one is for the financial calculator. So we will get the result like this for the financial calculator, like entities like amount, period, and all that results also, like outputs. And we will also get the note at the last, like future values, assume contribution, like, and all that. So in like this, we have different queries for different agents also. Like we have many agents here. We will get the appropriate accurate JSON for each of different agents. So this is the code, and we have agents, and I have also added the test here. So a non-obvious decision made was to put the safeguard before the classifier and make it fully local. So I did that because safeguard has to be deterministic, fast, and independent of model availability. So I also chose to let the classifier safety verdict, like to be information only. That means the guard is the only thing allowed to block a request. This avoids double blocking and keeps the decision boundary clean. So the guard protects the system while classifier helps with context and routing also. And another important decision was like keeping session memory like in memory for this assignment. This is not the most stable choice for production, but is the best trade-off is like but it adds zero infrastructure, zero setup, and very low latency. The interface is like isolated, so it can be later swapped for Redis or Postgres without changing the rest of the pipeline. So that's why I have added the in-memory. Like we can add Redis and Postgres later. So the fully implemented agent in this build is like portfolio health agent. Like the fully implemented agent is that. Like it takes the user's portfolio data and inputs and computes concentration, risk, performance, and benchmark in comparison, as we have seen that in the Postman. So it also handles the empty portfolio case gracefully by switching the build oriented guidance instead of failing. For noise investors, the matters because the system should help them start, not just evaluate existing holdings. So the service is designed to be testable without credentials. Like we can run all this test in CI. The test suite runs offline with the LLM mocked in CI. And also that means the core routing, safety, and structured response behavior all are verified without depending on OpenAI keys. I also added the response contracts explicit in Pydantic models and so the SSE payloads and agent outputs stay stable. If I had one more week, I would add two things. First, true token level streaming. Like I will have had the true token level system for if I have one more week. And it is useful for streaming from the agent layer so the user gets incremental content faster, not just final structured events. Second, I would replace the in-memory session storage with durable backend like Redis and Postgres and tracing. So we can measure latency and all that. So we can measure debug failures more easily in production. So these are the all agent implementations. Also, this is my session memory. So these are all the different types of portfolio agents like market structure, financial, and all that. And so these are the environments I have been using. So the cost and performance also are less as we are using the Grok and OpenAI. And if the metadata has high accuracy, then we'll fall back to metadata only without using the LLMs. So this reduces the cost. And we also have like in summary, this build focuses more on the spine of the system, like a real agent implementation and SSC like SSC based delivery. The key decision choice is to fail safely and predictability by keeping the system easy to extend with more agents later. Like I have had added more agents in this like market research agent, financial calculator, risk assessment, production recommendation agent, and predictive analysis agent, and customer support agent, and structured stub, like other stubs. Like so, let's go to the each agent. Like this is the customer support agent. We can have general queries in this, and this financial calculator will provide the query, and it will provide us the accurate like what how will be the calculation for the business and all that. And we also can know the future plannings of that, and also market research like how will be the growth of the company in the market. And this is the main agent we have implemented is like portfolio health. We use Y Finance and all that. And predictive analysis also we have implemented. Like it will go live on the market and all do all that. And the product recommendations also. Like we will check all the recommendations and will provide the best recommendations among them. And risk assessment. This is also an important where we will check all the risk in the before going into the market. We want and LLMs also in this. So this is the whole project. This is more durable, and we have gone through each and every step detailedly, like passing through session history or blocking through SSC metadata, and using the classifier and router to go to appropriate agent based on the user query and get the appropriate results under less time, like under 2 seconds of time, and like it uses the best result and best LLMs and with no and reduced cost. This is my project. Thank you.